Assalamualaikum warahmatullahi wabarakatuh and good day. Now we continue with conditional density function. So by definition 5.5, if y1 and y2 are jointly discrete random variable with jointly probability function of this one, okay, you have this jointly probability function. Then the conditional discrete probability function of y1 and given y2 respectively are given by this one. So if you remember, when you learn conditional distribution function or if you learn conditional probability, you have this notation. Okay, probability of y1 given y2. So similar for distribution function. Okay, density distribution function for discrete. Okay, y1 given y2. So this one actually you can write like this. If you remember, if this one, if you have p a given b, you will have p a intersect b divided by pb. Okay, probability b. So similar for this one, you will have probability y1 equal to small y1 given y2 equal with y2. Then this one you can have this notation. Okay, here your y2 should be greater than 0, otherwise it's undefined. Okay, so that one is for discrete. And then you have example 5.7. Okay, so refer to example 5.5. So if you remember from previous video, you have example 5.5. You construct this joint probability function for y1 and y2, okay, which is Democrats and Republican. Okay, you need to select two people in a committee. So the question asks you, find the conditional distribution of y1 given that y2 equal to 1. Okay, so that's it. Given that one of the two people on the committee is a Democrat. Okay, find the conditional distribution for the number of Republican selected for the committee. So based on the previous definition, so y1 you still have 0, 1 and 2 given y2 equal to 1. So if you look based on table 5.2, you can get here 0, 1 divided by 1, because here what is y1 equal to 0 given y2 equal to 1. So for sure the denominator here should have p2 equal to 1. Alright, so p2 equal to 1 will be this one, isn't it? 8 over 15, this one. Alright, and then here the first situation, when y1 equal to 0 and 1, 0, 1, you get 215. So 215 over 815, you will get 1 over 4. And then similar, you need to do for y1. y1 equal to 1 and y1 equal to 2. Okay, here we show greater than 2, but in the real selection we cannot have greater than 2 lah. But that's why if you look here, the probability is 0, because given y2 should be equal with 1. So the probability y1 to get equal with 2 is 0, not possible actually. Alright, so that is conditional distribution function. So that one for discrete. Now we will move to continuous. Okay, so definition 5.6. If y1 and y2 are jointly continuous random variable with jointly probability function for this one, right, respectively, then the conditional probability function of y1 given y2 equal to y2 is given like this one. Okay, so the notation here, you have distribution function y1 given y2. y1 should be less than equal to y1 and y2 equal to y2. So notes here, you must look. Okay, you must have for this distribution function, okay, it's a function of y1 for a fixed value of y2. So y2 will be fixed lah. Alright, and then you have definition 5.7. Let y1 and y2 be jointly continuous random variable with joint density function. So here you have joint density function and marginal density for fy y1 and y2 respectively. You will have this one. Okay, so the first one, for any y2 such that y2 greater than 0, the conditional density of y1 given y2 equal with y2 is given this one. So the concept is similar with conditional probability lah. Okay, similar like previous, when you have probability A given B, you will have probability A intersect B, PB. Okay, similar. So similar for this one. The conditional density of y1 given y2 will be like this, and the denominator should be greater than 0. If equal with 0, it will be undefined. Okay, we continue. For any y1 such that the functions greater than 0, the conditional density of y2 given y1 equal with y1 is given this equation. So this is similar with previous, but this one we want to find y2 given y1. Okay, so that's why here is the joint distribution function, but the denominator is focused on y1. Okay, and both the denominator here should be greater than 0. Now look examples 5.8, page 241. A soft drink machine has a random amount y2 in supply at the beginning of given day and dispense a random amount y1 during the day with measurement in gallons. So from this first sentence, you can see that given a random amount of supply water, okay, or here soft drink, and then you dispense a random amount water during the day. So y2 is a supply amount water, y1 is water that you dispense. Okay, it is not resupplied during the day, and hence y1 less than equal y2. So for sure the value of amount you dispense should be less than the amount value of water we supply in the soft drink machine. Okay, it has been observed that y1 and y2 have a joint density given like this. Okay, so you can see 1/2 y1 should be less than y2 and the value is between 0 and 2. That is, the points y1, y2 are uniformly distributed over the triangle with the given boundaries. So you can see that with the given boundaries, this is a uniform distributed. If you remember uniform, you have 1 over theta 2 minus theta 1, isn't it? So here 2 minus 0 is 2, then you get half here. Alright, so find the conditional density of y1 given y2. So if you look here, you will have f y1 given y2 equal to y squared. Okay, so what is the value here? Evaluate the probability that less than half gallon will be sold given that the machine contains 1.5 gallons at the start of the day. So this is the application of it. First of all, we want to find the conditional density first. So this one, based on the definition of previous slide, this one will be what? F y1 y2, and this one will be f2 y2. Okay, so if you look the solution, first we need to find the marginal. If you look here, this is the marginal density function, this is the joint density function. So the marginal density of y2 is given this one. Okay, from the previous video you learned the marginal density of y2, so you have this one. Okay, if you look marginal density of y2, right, it's between here y1, y2 is between y1 and 2. Okay, and if you find y2, you will focus on y1 here. So if you look y1, it will be 0 and y2. Okay, so that's why here first you need to find this one. How to find this one? You will find using this theorem lah. So basically here will be 0 until y2 half dy1. So when you integrate here, you will have half y1 0 until y2. So when you substitute, you will get half y2. Alright, because you substitute the value, so you will have this one. Okay, and then you look, y2 is between 0 and 2. And then for others, that means this is between 0 and y2. If you have y1 less than 0 or y1 greater than y2, what is the value here? So it will be 0. Okay, so this is the first marginal distribution function. Right? Okay, so now we want to find this one. So this is the formula that we have before in previous. So we know that this one is half. This one we get from here is this one, sorry, this is half square. Sorry, half y2. Okay, we have here. So here will be, you just substitute the value into this formula. You will get half over half y2. So this one, when you simplify, you will get 1 over y2. And then this one, the limit will be from 0 until y2. y2, what is it? 0 until 2. Okay. So also here, okay, we will look if y2 less than 0 or y2 greater than 2, it will be undefined here. Okay, you cannot have 0 here lah. Alright, and then the probability of interest, okay, the application, they want to see, if you look here, evaluate the probability less than half gallon will be sold given the machine contain 1.5 gallons. So contain 1.5 gallons given, which is your y2, y1 is less half than half. So that's when y1 less than half given y2 equal to 1.5. So this one, actually you will have this kind of function, okay, negative infinity to half, because your y1 is less than half, okay, but here you will change to 0 because the limit is from 0. And then here when your y2 is equal 1.5, so you have this one. Okay, inside here is the function of this one. Where do you get this one? This one. Okay, so y2 is 1.5, so you just substitute the value. Okay, and then here you integrate first. Actually you will get what? 1 over, let's say I didn't do this the calculation. When I integrate this one, I will get y1 0 until half. So when I substitute the value, I will get half over 1 over 5. So what is the answer here? 1 over 10. Okay, and this is another calculation. Let's say if change the machine contains 2 gallons at the start of the day, then what will be the conditional function? Okay, conditional probability that y1 less than half given y2 equal to 2. So you can see here, okay, we will have the same method like this, okay, but then here we will get half, integrate with respect to y1, so then we get y1, okay, then you substitute the value half, you get 1 over 4. Right, so you can see the changes to appreciable depending on the particular choice of y2. Okay, so that's the conditional probability density function. Okay, and then you will have exercise this one. So this is exercise consists of the marginal distribution function and conditional distribution function. Okay, you try do today and then look, do you understand or not how to solve it? Okay.